Hello everyone. Previous lecture we have studied the concept related with the chapter conic section, and in that we consider various sections in between the cone and the plane. Here we define the circle, parabola, ellipse and hyperbola. In today's lecture we go with the concept with the part parabola. Here we have to define the equation of the parabola, okay, and here different forms or different standard forms of the parabola. Firstly, we define the parabola. Here to define the parabola, we consider the locus of the points which are equidistant from the fixed point and the line. Suppose here this is our fixed point. This fixed point is S, okay. Then we consider one line. Suppose this is our line, okay. This is our line L, okay. We have to consider the points, set of points which are equidistant from this point S and from this line. Suppose here P be the any point here, okay, having coordinates here x, y. Okay, so here the distance SP is equal to distance OM. Remember here distance SP and the distance PM, we consider these two distance to define the parabola. If these two distance, here distance SP and PM are equal, if these two are equal, then here we define the parabola. Okay, here remember the ratio in between SP and PM here is always constant. Here is always constant. Okay, so here I write this SP upon PM and this is equal to E. This E is for eccentricity. Here E is for eccentricity. Then using this relation, here I write SP is equal to EPM. SP is equal to EPM. In last lecture, we see here everything is depend on this nature of E. If this E is 1, that is value of E is 1, then here we get SP is equal to 1 into PM, and lastly here we get SP is equal to PM. That is length of SP and length of PM here is equal, and using this part we define the parabola. Okay, now here remember this relation, here SP is equal to E into PM is called focus directrix property. Focus directrix property. Here this S is for focus, or this S is called focus, and this line L is called directrix. So using focus and directrix we define here focus directrix property. Okay, so this is all about our parabola. Now in today's lecture, here we have to define standard equation of the parabola. Okay, so we go with this part, standard equation of the parabola. Standard equation of the parabola. Here again to define the standard equation we consider the focus, we consider the directrix, and we consider one point P of XY. Here this point, or we consider the set of points or locus of points which are equidistant from the focus and from the directrix. Okay, so here we consider point. Suppose this is our point S. Then we consider one line. Suppose this line is our directrix. This line is directrix. Here we know this S is the focus. Here S is the focus. Using these two, here we define the parabola. Here we define the parabola like this. Okay, this is our parabola. Then we consider this point here, this point as origin. Okay, here to define the standard equation of the parabola, we consider coordinate axis, that is we consider x and y axis. Suppose this is our x axis, here is our x axis, and we consider our y axis which passing through the point O, that is which passing through the origin, which passing through the origin. So this is our y axis. Let us consider one point on the parabola here, P of xy. P of xy be any point on this parabola. Let's join here SP and we consider the perpendicular on the directrix which meet at M, Here we know for the parabola the distance SP and PM are equal. Here these two are equal. Okay, let us consider the point on x-axis. For this directrix, here is Z. Now to define the equation of the parabola, firstly we have to consider coordinates of the point S, P, M. Here for P already coordinates are given and are XY. Okay, here to define coordinates of S, we consider the distance of this S from the origin A here as A. If this distance is A, here coordinates of S are A0. Here are A0. Now we have to define coordinates of M. Okay, here remember if this distance OS is A, then we consider this as here A again. So coordinates of Z are here minus A0. Here minus A0. Okay, so we know this is here minus A, or this equation of directrix is here x is equal to minus A, that is here x plus A is equal to 0. The coordinates of M are here minus A y, here minus A y. Then by using the distance formula we find length of here SP and length of PM, length of SP and length of PM. Okay, so by distance formula, here we find firstly SP. Here for SP we consider square root. Okay, then we consider coordinates of point P and coordinates of S. Then here we get x minus A, this bracket square, plus y minus 0, this bracket square. Similarly for PM we use a distance formula. Also here for PM we consider square root, and inside the square root we consider the coordinates of the point P and M. So here we get x plus A, this bracket square, plus y minus y, this bracket square. We know y minus y is always 0, so here we get only x plus A, this bracket square. Now by using focus directrix property for the parabola, here we know SP is equal to PM. Okay, so I write directly here by using focus directrix property, here we get SP is equal to PM. We know SP is a square root of x minus A, this bracket square, plus y minus 0 bracket square is equal to, then Pm, here Pm is square root of x plus a this bracket square. Now squaring on both the sides to remove the square root. Okay, so here squaring on both sides, squaring on both sides, we get, here we get x minus a bracket square plus, we know y minus 0 is y, and here we get y square is equal to, then here we get x plus a bracket square. Let's expand this to bracket, x minus a bracket square and yx plus a bracket square. Here we know x minus a bracket square is in the form a minus b bracket square and is a square minus twice ab plus b square. Similarly here we get x square minus 2ax plus a square, then here y square as it is equal to, here we know x plus a bracket square is in the form here a plus b bracket square and is a square plus twice ab plus b square. Similarly here we get x square plus twice ax plus a square. Now here x square from both the sides are cancelled, a square from both the sides are cancelled. Okay, here only remains minus twice ax plus y square is equal to twice ax. Okay, then in next here we get y square is equal to 2ax plus 2ax. We know 2ax plus 2ax is 4ax. Therefore, here y square is equal to 4ax, and this is the standard equation of the parabola. This is the standard equation of the parabola. Remember, this y square is equal to 4ax. So, we define the standard equation of the parabola. Here first is y square is equal to 4ax. Remember this equation. Now we go with our next two results. In that we define firstly focal distance. Firstly we have to define the focal distance. Okay, so we go with this part, focal distance. Okay, here in this figure, this SP, this distance SP is called the focal distance. That is, the distance of SP is called focal distance. And to define the focal distance, here again we have to consider the distance in between SP and PM. That is, we have to consider the focus directrix property. Okay, suppose coordinates of point P are here P of x1, y1. Here are P of x1, y1. Consider coordinates of S as here a0, then coordinates of M as here minus a y. So directly by using here minus a y1, we consider minus a y1. Okay, so directly by using the focus directrix property we get focal distance. So using focus directrix property we know here SP is equal to PM, these two are equal. Let's define this PM by using the distance formula, and for this we know coordinates of point P and coordinates of point M. So here we get x1 plus a bracket square plus y1 minus y1, this bracket square. We know y1 minus y1 is 0, so this is equal to square root of x1 plus a bracket square plus 0. then we get here inside here the square root x1 plus a, this bracket square, and lastly we get here x1 plus a. So here the focal distance is x1 plus a. Focal distance is x1 plus a. Here I write this is focal distance. Here is focal distance. So remember this equation, this focal distance also. Now we go with our next part, and in that we consider the length of latus rectum. Length of latus rectum. In next, here length of latus rectum. Length of latus rectum. Firstly, we define the latus rectum. Okay, here remember latus rectum is a chord. Is a chord which is perpendicular to the axis of symmetry. Remember, I repeat again, here latus rectum is the chord, is a chord which is perpendicular to the axis of symmetry, and this chord is passing through this point S, passing through the point S. Okay, so we consider one figure to define the latus rectum. Here again we consider point. This is our fixed point S. Then we consider here directrix. This is our line and is here directrix. Here is directrix. We consider one parabola like this. Okay, this is our point O. Our axis or y-axis is passing through the origin like this. Okay, then here we consider one point on this parabola. Here is a p of xy. Okay, then we consider one perpendicular for the directrix. Suppose this is PM. Here PM is the perpendicular to the directrix. Okay, we consider the x-axis. This is our axis. This is our x-axis. Okay, then we consider here coordinates for this S as a 0. Okay, then we consider coordinates of M as minus a y. Here is minus a y. Here latus rectum is a chord, which is perpendicular to this axis, x-axis. Okay, like this, which is perpendicular to the x-axis and passing through this focus. Okay, so here end points of latus rectum are L dash are the end points of the latus rectum, and here we have to find the length of this latus rectum, L dash. Okay, and to define the L dash, we consider here AL distance as L, then here AL dash here as L, that is both is of same length, both are having the same length. Okay, so by the symmetry of the curve, by the symmetry of curve, here we get here L dash S is equal to LS is equal to L dash X and is equal to L. Here is equal to L. Here coordinates of this L are here coordinates of L are here A, L. This distance OS is A and this LS is L. Okay, and coordinates of L dash here are minus A L. Here is minus A L. That is here this distance, this is minus A, so minus A L. Okay, so these are the end points of the letters rectum. Since this L, this point L lies on the parabola, okay, since L lies on the parabola, y square is equal to 4ax, here we get, let's replace here y by using L and x by using A. Here we get L square is equal to 4a into x is A. Okay, then we get here L square is equal to 4a square. Therefore, here L is equal to plus minus 2a. L is a plus minus 2a. Okay, so we get this half L. Here L is 2a, this L is also 2a. And here we know here L dash is 2 times L, is 2 times L. Consider here length of letters rectum is equal to 2 times L. We know L is 2a, so 2 into 2a and is equal to 4a. So 4a is the length of the letters rectum. 4a is length of the letters rectum. So remember this part. Here we also define the end points of the letters rectum. First is here L. Okay, so L is equivalent to AL and is equivalent to here A into here L is 2A. So A to A is the first point, and here L dash is equivalent to A minus AL is equal to minus A. Then L is 2A. Okay, so here L dash are the end points and their coordinates are like this. Their coordinates are like this. So up to this point, we define the focal distance. Then we define the length of the letters rectum. Okay, so here we define the standard equation of the parabola, which is y square is equal to 4ax. Here we have some other standard forms of parabola also. Let's define these standard forms. Here first is y square is equal to minus 4ax. Y square is equal to minus 4ax. Here again, to define this parabola, we consider one point. This is our focus S. We consider the directrix. This is our directrix. Then we consider the coordinate axis. Suppose this x-axis passing through the point S. Okay. Then we consider here y-axis. Suppose here y-axis is here. This is our y-axis. Okay. Then we consider one parabola like this. Okay, this is our parabola. Here, okay, I repeat, here we consider one parabola which passing through the origin. Okay, like this. So here this is our origin O. Here S is the focus. Here this first line is the directrix. We consider the y-axis. So here for the y square is equal to minus 4ax, our figure is like this. Okay, so remember this figure. Here the equation of directrix is, here x is equal to a, that is here x minus a is equal to 0. This is equation of the directrix. Okay, here the coordinates of S, that is focus, are here minus a, 0. Let's go with our next form. Here is x square is equal to 4by. Second is x square is equal to 4by. To define this type of parabola, we consider one point. Suppose our point S is here, okay, and having coordinates here. Okay, this is our point S. Then we consider the directrix like this. This is the line, and we call this as directrix. We consider the coordinate axis. Suppose here our parabola passing through the origin, here passing through the origin of the x-axis like this. So this is our parabola. Here coordinates of S are 0, b. Okay, we consider the y-axis. Here y-axis is the axis of symmetry. Y-axis is axis of symmetry. So here for the x square is equal to 4by, our figure is like this. Then we go with our third standard form. Here is x square is equal to minus 4by. Here again, to define this parabola, we consider the fixed point. Suppose S is the fixed point. Then we consider the directrix. Okay, here is our directrix. Then we consider the x-axis. This is our x-axis. Here is a directrix. Okay, then here the parabola passing through the origin like this. Okay, then here axis of symmetry is on y-axis. This is our y-axis. Here equation of this directrix is, here y is equal to b. That is, here y minus b is equal to 0. Okay, then here coordinates of this S are 0, minus b. Here for the directrix, our equation is y is equal to minus b. That is, y plus b is equal to 0. So these are our another standard forms. Here y square is equal to minus 4x, x square is equal to 4by, and x square is equal to minus 4by. Okay, so remember these forms also. Okay, then in last we go with our general form of the parabola. General form of parabola. Here we know, here one of the standard form of the parabola is y square is equal to 4ax. Okay, and this parabola is having vertex is at origin. Is having the vertex is at origin. If we shift this origin to hk, okay, if the vertex is shifted to point hk, then we get the general form of the parabola, and here equation of the general form is y minus k bracket square is equal to 4a into x minus h, this bracket square. So this is the general form of the parabola. So in today's lecture, here we define the equation, standard equation of the parabola, we consider some other standard forms of the parabola. We define the focal distance, we define the length of the lattice rectum, and last here we define the general form of the parabola. In next lecture, we are going to see some important examples related with this part. Thank you.